Hello and welcome to Physics A-Level at the Emmbrook School. My name is Mr. Curry and I'm just going to lead you through a bit about what we do in this subject at the Emmbrook. So physics essentially is the study of mechanics, fundamental constituents of the universe, so subatomic particles, matter, energy, and this range from the fundamental particles inside atoms to the theory of alternate worlds and exploring our own universe. And we will go through a variety of topics and concepts that start to help us build on these ideas. Some great unanswered questions of physics that the best scientists in the world still have not quite got the hold of. What is matter made of? Why is gravity so weird, and ultimately why is it caused? Why does time seem to flow in one direction? Where did all the antimatter in the universe go? What happens in the grey zone between solid and liquid? How can we find a unified theory of physics that is linking general relativity with quantum mechanics and getting everything to just fit nicely? And how did life evolve from non-living matter? So some things that are yet to be discovered, but hopefully you will start to develop some understanding of how we might go about approaching these discoveries in the 2 years you spend with us. Some benefits of being a physicist today: obviously finding out why the world and universe works the way it does, being able to solve problems. It has a very wide range of career opportunities, some more specialists, some less so, but having that background can help you get an advantage over your peers when going for jobs. It keeps you on your toes and keeps you thinking kind of actively. It complements and is complemented by different subjects such as maths and technology. It will challenge you, certainly more than many other subjects you could take at A-level. You could work overseas, internationally, and you would acquire skills valuable to many employers once you leave school and move past university. There are many careers using physics. As I've said, there are some that are more specific, like accelerator operators, engineers, design engineers, laser engineers and such. Software developers. There are some less specific ones, such as IT consultants, data analysts, so still using a mathematical or computer science background, but not necessarily going fully into the physics side of things. And many companies that will always look for someone with physics training: Boeing in the aircraft industry, Bosch, CERN, Cisco Systems, which are a large communications company in America, GlaxoSmithKline, Jaguar Land Rover, and many other car companies, IBM, Microsoft, NASA, and many more, obviously. Our course is OCR at Physics, and it is split into 4 modules across 2 years. We have generally Year 12 approaches, kind of consolidating your GCSE work, getting everyone up to a nice uniform level, pushing the boundaries of some of the mechanics and forces and electricity a little bit more, but generally just making sure you're comfortable with physics as a topic. As we move into Year 13, we get into some more challenging areas. This would involve more work in fields, electric, magnetic, gravitational fields. We begin to look at radioactivity in a lot more detail. As you do thermal physics and space, you really start to explore that to a much greater degree than you ever would have done at GCSE, and your math skills are really going to start to develop throughout these topics as well. Ideally, to study physics at Emmbrook, we would be looking to have you get a grade 6 in the physics GCSE or combined science higher tier. A grade 6 in maths and English ideally is going to put you in good stead for completing the course. You will need to be able to put your mind to your work, working independently and in teams. And ideally, you'll be preparing ahead of your lessons by reading in the course books and looking online, as well as consolidating that learning, possibly by rereading similar textbook pages or going to other study sites just to reinforce anything you have learned in lessons. As well as reading beyond what is required, as this is always going to give you a good foundation on which to build further knowledge. We'll be learning new topics every week, which will be assessed by end of topic assessments, as well as end of term kind of mock papers to make sure that we are progressing properly and to identify any areas we may need to strengthen. Ideally, you'll also have a thirst for knowledge and really be eager to pick up the information that's being delivered to you throughout the course. By the end of year 12, you will have studied quantum physics, and this is an example of a question you may be able to use to answer. So we use graphs in a lot more detail in GCSE. It's not always just about finding the gradient. It's about understanding what all the features of the graph will represent to you. This is something you can try having watched the video, but certainly we will get a chance to look at all these kind of questions throughout the course. Okay, and a mark scheme just to check that if you have had a go at home. By the end of year 13, we begin to merge a lot of the concepts. So this is a question that brings together equations for motion and kinematics for projectile motion and applies it to the nature of an electron passing through an electric field which has previously been accelerated by a potential difference on the left there. So bringing your particle acceleration, fields and projectile motion all in together and trying to make sense of an unknown equation that you would have yet seen until you sat this exam, for instance. And again, the mark scheme, just so you can see if you've got a handle on that, have you attempted it at home. So some of our students have gone on to study pure physics, including Oxford candidates. Many have gone on to apply their physics background to engineering, and similarly architecture, and as well as is a growing industry, many of our students have gone on to do computer science. So all typically quite high up academically in terms of their degree level, and typically as well prospects look good for graduates in science subjects. Okay, so the Independent said that certainly applies to students on science, technology, engineering and maths degree courses whose qualifications and skills appear to give them a better chance of getting on the first rung of a career ladder than those from other subject areas. So they are very kind of niche courses really. There's only a select few, if you consider the population, that go on to study these kind of things, and they do give you an upper hand in the job market once you're out of university. So that has been physics at the Emmbrook School. If you have any further questions, please contact me at jcurry@emmbrook.wokingham.sch.uk.